I will be talking about unit tests that the first 3 parts will be dedicated to Apache Spark structured streaming, and the 3 remaining parts will be more generic, that we will be able to apply them to structured streaming. But if you have batch pipelines with Spark SQL, you will obviously be able to use these recommendations as well. So my name is Bartosz Konieczny. I'm a freelance data engineer and trainer. I'm also blogging at waitingforcode.com, so that you can reach me out at contact@waitingforcode.com. And currently, even though I'm working still with batch, for 2 years, I have been fully focused on stream processing. It means deep dive into structured streaming. It means that also I'm learning a little bit better or more Apache Flink, which is a different technology, but as fascinating as Apache Spark. And additionally, since the last year, I'm also writing a book about data engineering design patterns. 2 chapters are already available at the O'Reilly platform, and the whole book should be there hopefully next year. I'm currently writing the chapter 8, but the edition adds an extra latency, so hopefully it will be there in the end of the year or in the first months of the next year. You can connect with me on LinkedIn if you want, and let's get started. I bet that when you write unit tests, the first problem you will face is the code structure. And the code structure is very important because it will let you, as an engineer, to better understand and maintain the code, but it will also enable you to write unit tests, because if you kind of compact all the business logic in a single functions, you guess it will be not easy to add and write unit tests. And I have been facing kind of challenge for the past years when I was wondering if there is a way to kind of standardize the project structure with Apache Spark structured streaming, and I'm fine with that each team has its own practices, its own recommendations and habits. And I was wondering if there is a way to kind of make everybody happy and propose kind of generic structure. And what I'm proposing each time is this code organization based on the data flow model. So if you don't know what the data flow model is, no worries. There is a kind of 3 questions that are included in this model that should help you understand it better. Of course, it's a much more advanced concept than just this, but in simple terms, data flow model defines streaming query in terms of 4 questions. The what, obviously, is your business logic. The where, which applies to the event time, so the event time of your data. The when, that works for the processing time, so when in the processing time you materialize your results. And finally, the final question is how, so your job will handle accumulated data. And despite all these questions are fully related to data flow models, so to GCP data flow and Apache Flink that implements it, we can try to somehow transpose them and apply to Apache Spark structured streaming, even though they are not fully, I would say, compatible with the microbatch model that Apache Spark proposes. But still, it helps to get some better idea on what kind of generic concepts you may have in a structured streaming job. So obviously, for the what part, it's very clear, is your transformation logic. So each select, each map bin pandas, map bin arrow, arbitrary stateful processing functions you write, filters. For the where, here Spark limits to the watermark. So the time stamped column that you add to, for example, control how long your state will be stored in the state store. The when finally, it's the easiest one in Spark because it's obviously based in the microbatch, and microbatch is based on triggers, and one of the most common triggers is the processing time trigger. So the correlation between processing time of data flow model and processing time of Spark is very obvious. And finally, the how it applies to output mode. So when you are working with stateful processing, you can define one of 3 output modes. The append one, which applies to the state. So when you use the append mode, the emitted state by your stateful operations will be always the final one. It will not get updated. When you use the update one, you will get each time when your state gets some new attributes, get new values, the operator, the stateful operator, will emit these updates to you. And finally, there is the complete. And in the complete, each time you get the full state store. And to not be kind of abstract, of course, you can apply it. And yeah, I wanted to propose kind of simple and difficult project, structured streaming project to you, which processes the visits data that I am generating from my generator. So it's doing kind of simple reading, grouping by key, arbitrary stateful processing, data enrichment, and finally data emission. So I use this arbitrary stateful processing because it's simple and difficult at the same time. So it's difficult because, of course, it involves working with a state store, and the state is less obvious than the stateless jobs. But it's also simple because it doesn't involve any tricky parts like having multiple watermarks in your query or joining two different, for example, streams. And it pretty well, it's a pretty good illustration to this data flow model in Apache Spark. So when you apply the data flow model to that, the dominant part are the what, obviously, because it represents your business logic, which means the reading part, the mapping function you implement, and also the enrichment. The where, so the watermark is in the group by key expression because each time both are follows in stateful operations. And finally, there is the write part. The write part where the when and how, as I said, they are correlated because each time when you define some trigger, at the same level, approximately you define the output mode in the stateful processing. So both are correlated. And let's see now a few examples. I will not give you all the examples. I will just show you one example for each part. And all these examples are present in the GitHub repo that I will share in the end of this talk. And an important part is that I'm not testing here, or I'm not annotating here the IO parts because it's already tested. Unless you are using kind of custom projections, I think it's possible in JDBC connector, when you can, for example, define a SQL query that will be pushed down by Apache Spark and returned to you with different data frame than the data which is present in the table, not the schema which is present in the table. So when it comes to what, so the business logic is a kind of projections we are doing. For example, here we are extracting the visit and mapping it to the state of the visit. When it comes to where, so here, as you can see, there is this watermark expression, tiny couplet with group by. So this is this event time application. And finally, there is the when and the how for the writer part, where, as you can see, there is output mode and the trigger. And I'm not dogmatic about this part. You might be thinking that it doesn't worth testing it because there is kind of output mode and the trigger, which are kind of fully managed by Apache Spark, and it may not be worth it testing it. But in the end, it's also kind of expression of your business logic, of your business requirement. So you don't want anybody to change the output mode and to emit, for example, wrong results or deploy the job even on staging and try to understand what's going on. It's better to understanding it on your local machine or in your CI/CD pipeline. And overall, the job looks like this. So we have this IO part, which is fully abstracted. And it's also very important because it's a simplification for writing unit tests. You don't need to emit data to Kafka, even with the local containers. You can simply create a data frame and it should work. But unfortunately, it was only the first challenge. Once we have the project structure, now we need to find a way to perform the assertion. So to ensure that the code you are writing, you are testing, the code you wrote and the code you are testing fulfills and responds to your business demands. So in batch, it's relatively easy, right? You have your input, you have your transformation logic, you have your output, and on top of this output, you can assert the expected results. And here, we can consider this batch job as a kind of a stateless job in streaming because it doesn't combine anything with the past observations. Whereas when you have some kind of a streaming job, and additionally, which is performing some stateful operations that increments the results that are processed over time, you have something like this. You have your first results, you have your second, and you have the first results. And the challenge here is to find a way to first control these results, and second, assert on these particular results, but it will be the challenge number 3. So let's stay focused on this second one and see how to assert these 3 loops. Yeah, because it's a kind of for loop that you need to write in a control manner so that you can add your data, process it, assert the results. Add your data, assert it, and process the, add your data, process it, and assert the results, and so forth and so on. So that's the big challenge. And Apache Spark has kind of facility for that, which is the process all available method. When you are using structured streaming, I bet that probably most of you use this await termination method that has an optional TTL, timeout execution flag. Unfortunately, you can technically, but it's not, I would not recommend using it for the unit test because it's kind of unpredictable. So you don't know whether your test will take 10 seconds, you will take 20, or on different computers it may even longer. And that's for the reason Apache Spark has this kind of facility function, which is the process all available, which, as you can see, replaces the await termination for structured streaming. And when you take a look at the code test snippets, you can see that we are doing exactly what I said before about this controlled loop. We are generating, so I didn't put generating data because I didn't want to have this slide too long, but we are generating data first. Later, we are declaring our business logic that we want to test. We are using now, after that, the for each batch synced, it corresponds to the challenge number 3, and we call the process all available. At this moment, Spark will stop the main thread, and it will process all data which is available for the given microbatch. And we are doing it so far and so on with the next, I would say, loop executions. And an important thing is that you may be also be a little bit surprised to see that this processing time in the previous snippet was configurable, because obviously when you deploy a structured streaming job, you are deploying it with a fixed and static processing time trigger that will be the same obviously on all environments. But the reason why I left it as dynamic, it was to enable these testing purposes, these testing facilities. Of course, you can always play with the defaults if you don't want to have this one changed for your production job, but that was the main reason, that as the project structure enables easier testing purposes. And the processing time trigger is also very important for this process all available function, because how does it work is that there is this no new data flag that the process all available sets to false. It processes the data, so the main thread is stopped, and later it executes the next microbatch. So logically, if you use the microbatch of 30 seconds, for example, you will need to wait 30 seconds each time to know whether there is new data to process or not, whether your main thread can release and continue or not. Obviously, your test will be very slow in that case, and you don't want it because unit tests are supposed to be very fast and run very often. So yeah, if you use production time trigger, take care, but be careful because it can be really slow. And you may be also thinking that, okay, I don't know this process all available, but I know the available now that was added, I think, 2 versions ago. And why not using it? Technically, it's a valid solution also because it does the same thing. It follows kind of the same pattern, but it semantically is a little bit different, because when you take a look at this snippet, you can see that we are starting and stopping the query, meaning that we are each time we are doing that, we are interacting with the checkpoint location. So we are loading the metadata to streaming query. We are starting a new streaming query each time, in fact. And it's more like running kind of batch processing, but with unit tests. So both solutions work, but I think that you need to adapt the good one for your project and for your practices. And now is the challenge number 3, which is the scoping the microbatch, so getting the results that are generated in each iteration. And here you already got kind of answer with this for each batch function. Here we are focusing on these 3 blocks. We want to capture these 3 blocks and assert that the results are corresponding to our expectations. And to do that, Apache Spark has 2 nice abstractions, data stream writer, which is, I will define it later, and the batch ID. So data stream writer, according to the Scala doc, is an interface, so it's not an implementation that you can later configure for a specific use case. So you can configure it to write to Kafka, to S3, to any kind of storage. You can also configure it to write to the memory, but you can also configure it to write to this Apache Spark Swiss knife, which is the for-each batch processing, because you probably know you can do a lot of things with that. You can do the fan-out processing. You can also use batch syncs, and you can also leverage it to write and to capture the data for unit test assertions. And how does it work? So in this snippet, you can see that the function returns the data stream writer from this setup session writer plus the checkpoint location, which is configurable, because I didn't want to put it too low, too deep in the code base. And later we have this helper class that is data to asset writer and reader. Okay, name is maybe not the best one, but the idea here is to run this write to test output dir function whenever you produce new data for the unit test incremental. And we are doing, as you can see, a simple collect. Remember, we are in unit test world. Collect is maybe not recommended in big data, but here we are supposed to have less data to process and And we are building a dictionary between the microbatch number and the data that was generated in this microbatch. And in the end, there is this helper method, getDataFrame to assert, that retrieves the entry for each microbatch. So I did it because I'm coming from the Java world and I like the getters and setters. And overall, it gives you something like this. So we have our process all available, and later we get the assertion, the data, and we perform the assertion. So you can see that for the microbatch number 4, the generated data should be empty, while for the microbatch number 5, it should not be empty. But there is a gotcha. The gotcha is this get results to assert for the last microbatch function. So whenever I write it and I use the number-based version, sometimes I'm getting the flaky test. And the flaky test is the test that runs probably well on your machine one day, and tomorrow it doesn't run that well, it fails, without doing any apparent code changes. And it's simply because there is some kind of race condition between the process all available and microbatch execution. In theory, when you run stateful processing, you should have 2 microbatches. The first microbatch, which is for your input data, that may change according to your output mode. And the second microbatch, which is for the state expiration, of course, that runs after and evicts any rows that are persisted in the state store. From time to time, when I'm using this approach, I have 3 microbatches, one for the data, so the number 4 still works. Later, the number 5 that processes empty data frame, and the number 6 that processes that applies to the state eviction. So that's the reason I'm using this kind of trick and helper function. And yeah, friendly advice: avoid doing the assertions in the for-each batch function, because typically you read things up to bottom. If you put the assertions in the for-each batch, you would need to jump a lot between your unit test, between your input data and the expected results, so that it will be very difficult to follow, and I think you will be tired of if you have many tests doing that. Eventually, so here too I'm not dogmatic. If you don't care about the intermediate results, you can also test the final one. And if you want to test the final one, there is a built-in operator in Apache Spark, built-in sync, which is the memory table. And in this memory table, you have just to define your table name in the query name function, and later perform some SQL queries whenever you want. So here I'm performing the select in the end of the query, because I do care only about the final results that are generated by the test scope, of course. Okay, now we are going to the part which can apply to both structured streaming in Apache Spark SQL. And the first thing to do is this execution time, because as I said previously, unit tests are kind of at the bottom level of your test pyramid, and you should be running them often. They shouldn't take a lot of time, because of course, if they take dozens of minutes, you will not run them very often. And they should give you the feedback in a very clear and exact manner. So the first challenge here is the time execution. And in Spark, the test can be slow because of kind of two categories. The first is Spark related. And here, when you play with just these two first configurations, so the UI and shuffle partitions, you will get a huge gain in the performance. So Spark UI, of course, in the unit test, you have a limited set of data, so you control it fully. It's not like on production when you may need to debug and see whether there is some skew or anything. Here you are fully the master of the data. And why do you need the Spark UI? So that's the question. You can, of course, enable it from time to time to see how it's going on, but 90% of the use cases you will not do this. And the same for the shuffle partitions. You have small data. You don't need 200 shuffle partitions, 200 I/O buffers that will create and manipulate your disk, and of course slow down everything. There is also other properties that are more related to streaming, but they may give you some gain if you run, for example, validation test or something by increasing this housekeeping task. But these two first will be enough for most of the unit tests you will write. And there is code dependencies. So the real nightmare is when you import a third-party library and you have some kind of thread slipping to deal with the asynchronicity. So that's something you cannot do a lot, but it exists. And when you have some latency, it's always good to check whether it's not the case. The processing time trigger, as I said before, it can also be a performance killer. And big data set, of course, when you need to build and manipulate big data set, while you just do care about 1% of these of the rows. And of course, network and external dependency. So in unit test, everything should be that close as possible to the memory, to disk, and you shouldn't rely on the network for them. And just to give for the record, in the test project, I'm sharing in the end on my GitHub, just by fine-tuning these two properties, you can go to 21 seconds, 22 seconds of the execution time from 2.5 minutes. So it's a huge gain, and if you are not using them, give them a try. And now it's time for the 5, before the last challenge, think less assertion. So here I'm doing the poll for the first time. I'm not presenting for the first time, but the poll, yes. Can you spot the differences between these two? Can you detect easily the errors, in fact, in these assertions? I think no. And what about now? Is clearer or not? Yeah, okay, I have some thumbs up. Yeah, it's clearer. And that's because we are using kind of thinkless assertions library. If you didn't see the arrows, I just put the arrows. So when you're using Scala Spark, this library is called Deflicious. And as you can see on the screen, it compares kind of left to right, which for me personally, again, it's easy to read. I'm always try to propose this, but yeah, if you prefer column-based comparisons with data frame, your practice works too. When it comes to Python, there is this library PyTest Clarity, which does pretty the same thing, but it does it horizontally. And there is a glitch, is the library maintenance. It has not been updated for 1 year, I think. So it still works with PyTest, but there is no maintenance, unfortunately. And if someone has a hint why these kind of things are not added to Scala test, to GUnit, to PyTest, I will be happy to learn after the talk. And there is also something else that you can use to make your tests more human-friendly and with which you will engage a little bit more, is the PyAssert. So here you change literally your practice, your reading and declaration mode from left equals to right to something like I want that this be empty or has the length of 5. So here you can see an example on the screen. Assert that state pages for our pending visit session should contain these 3 records. And when you, as I said, when you want to stick with the data frame comparisons, there is 2 libraries, Cheese by Matthew Powers and Spark Testing Base that has some testing facilities by Holden Corau. And I missed the news, but yesterday I learned that the comparisons the data frame comparisons are already natively available in PySpark 3.5. So you may not need Chispa for that. And finally, there is the last challenge, Fluent and Pine-free dataset generation. So again, probably when you start your unit test, you pick some data from staging, from development, maybe from production even. You alter some attributes that will fit to your test expectations, to your test logic, and you will leave it in assets directory or module. It works for one test, but what if you have more of them? The maintenance can be very difficult. And there is an easy way to overcome this issue, which is one of the easiest, the simplest design patterns, which is the builder design pattern. And as you can see here, I'm just predefining some attributes for the visit. And later in the test that I will show in the next slides, I will just focus on the ones that are relevant to the unit, the test. And that's the whole purpose of this builder pattern. So yeah, you just skip what is not important and focus on which is important. I'm not saying that, for example, the referral property is not important for the processing, because if you have some transformation based on it, of course you will need to change it. But at least when it happens, you will not need to play with event time with user ID or other attributes. And here is an example. So here we are testing the extraction. And as you can see, the most important attributes for the test are the visit ID, event ID, page, and user ID, according to this projection schema you saw just in the beginning of this presentation. And that's the whole purpose. And it helps also keeping their definition readable, so you don't have to worry about multiple files accumulating and that you may need to change in case of any schema evolution. Unfortunately, it's not all, so there are other challenges, like who is guarding the guards, which means whether you don't have any data representation skew, whether your tests are correctly written, so when you have different input than the one which is expected, do they fail, stuff like that. But yeah, I have 30 minutes, so I will maybe cover some of them later in my follow-up blog post. And as a takeaway, so data flow model, even though it's by definition is related to the Apache Flink GCP data flow, it can also be used in our Apache Spark jobs to kind of define the project structure. The project structure, which is the enabler for easy testing. IO API, of course, you don't add an extra overhead, it's already tested unless you are doing some custom projections, some custom operations. Custom operations, I mean when you don't use the IO API in a declarative configuration only manner. Be explicit, so do not make you and your colleagues think about the failure, as we saw before. Keep the user engaged, because if they do not engage, obviously nobody will test. You will maybe spend some time on adding unit tests, but at the first failure, people will not understand and they will simply ignore them, because there is some annotations to ignore failing unit tests. And the performance as well, it plays in the user engagement part. The same consequence that the people will not add tests because it will be slow. They will prefer to deploy the job or maybe do other weird things, while its unit tests are there to block any side effects and maybe difficult debugging on much more volume of data. And I have all the resources here. The GitHub repo with the code snippet in Scala, in Scala and Python are in the GitHub. If you have heard about data flow model for the first time, there is a free blog post by Tyler Akidau, who was working at the time at Google, and he explained a little bit better these 4 questions. There is also a great book by O'Reilly about this data flow model, written by Tyler Akidau, Slava Chernak, and Roy Van Lax. And finally, there is a free talks I really enjoyed while I'm still monitoring this testing space. Last year, Jacqueline Bilston explained how to organize, how to address an issue with a big test case and to simplify them. She applied that to ETL pipelines in batch, but the logic is universal. You can use it in streaming as well. 5 years ago, I think Burak Yavuz presented some kind of operationalization challenges for structured streaming jobs. He talked about test harness, which is used in Apache Spark code base, but I didn't use it in the presentation because I wanted it to be kind of language agnostic, so that the concept that I presented here you can use in Scala and in Python. And finally, there is my last discovery from this year, Dennis Duman, who is a unit test advocate and trainer. He shared his 25 laws of test-driven development, and there is very important things to remember. He just gives the recommendation and doesn't force you do anything. You should always, as with this presentation, you should always adapt it to your team, to your habits. And maybe, finally, I will publish some follow-up blog post under this tag. And you can scan the QR code. Again, I'm doing it for the first time, so it expires. I'm really sorry, but all the links are in the GitHub repo README. Anyway, so thank you very much. We have 9 minutes for questions. Yeah, thank you.